Hi everyone, welcome back, and today we are going to see about the speed control of induction motor by using Kramer method. So already we've seen the few types on stator side, the next one rotor side control. So from this rotor side control, now we are injecting the EMF into rotor circuit. That is called slip power recovery scheme. So in slip power recovery scheme, there are two types. One is called Kramer system and another one is Cherbier system. So now we will see the Kramer system. Okay. So before that, we should know what is slip power recovery scheme. So in this slip power recovery scheme, so here this is the method which is used to control the speed of induction motor by injecting the voltage in a rotor circuit. The main thing is we are injecting the voltage in a rotor, not in the stator side. Okay, understood? Okay. And next, so here we must inject the voltage at the same frequency as supply. We are injecting the voltage in the rotor at the same supply frequency. If the supply frequency is 50 Hz, the injecting voltage into the rotor is also should be same frequency as 50 Hz. Okay, and there is no deviation should be there. And so now if you are the injecting voltage into the rotor which is opposing the induced EMF, that means the rotor resistance will increase. Suppose if you are injecting the EMF which is in phase with the rotor induced EMF, so the rotor resistance will decrease. So if the rotor resistance is controlled, the speed is automatically controlled. Okay, so the main advantage of using this method, the wide range of speed control can be possible. It can be either above the rated speed or below the rated speed. So in order to achieve this methodology, we can use either Kramer system and Cherbier system. So this is the block diagram of a Kramer system. So in this Kramer system, so this is the main motor. The speed has to be controlled. So the main motor which is connected with the three-phase power supply. So we have to control the speed of this main motor. Okay. So next, the slip ring, the rotor of the three-phase, the rotor of the main motor, which is connected on the AC side of the rotary converter. This is called a rotary converter. So there are two additional equipment. One is called DC motor and another one is rotary converter. So the main motor of the slip ring which is connecting on the AC side of the rotary converter, and DC side of the rotary converter which feeds the DC motor, which feeds the DC motor. Okay. This DC motor which is directly coupled, with the main motor. Okay. So here the main thing, the first one, this is the main motor. We have to control the speed of this main motor. The rotor of this main motor which is connected on the AC side of the rotary converter and the DC side of the rotary converter which feeds the commutator of the DC motor, and this DC motor is mechanically and directly coupled with the main motor. So now for the excitation of DC motor, we need the external DC power supply. So with the help of this external DC power supply, we can able to excite the field winding of DC motor. Once the excitation is getting variable, the induced EMF in the DC motor is getting changeable. Once the induced EMF in the DC motor is getting variable, so the DC side of the rotary converter is also getting changeable. If the DC side is changeable and the AC side of the rotary converter is also getting changeable. So once the AC side of the rotary converter is getting variable and changeable one, so that can be injecting into the rotor of the main motor. So that voltage, that AC side of the rotary converter, that injecting voltage is given into the main motor of the slip ring, so that it will oppose or it will in phase with the rotor induced EMF of the main motor. So based on the in phase or in opposition, the speed of the main motor is getting variable. So that is the main concept of this conventional Kramer system. Conventional. So if it is this is conventional means this with the help of rheostat and some other methodology. If we go for solid state, we are purely using the power semiconductive devices like IGBT, thyristor, GTOs and etc. So these are the procedure, and this main advantage, it can be used very large motor above 4000 kilowatt such as steel rolling mill. That is for the special type of speed control. This is one type of special type of speed control which is above 4000 kilovolt. And the main next advantage is smooth speed control is possible, and wide speed range of control is also possible in this method. Okay, and here the another advantage, the design of rotary converter is practically independent of speed control record. So, and this is an assessment, an energy efficient application for what does the slip power recovery system fit well. This is for screw gauge and slip ring motors, AC induction motor, slip ring motors only, and none of these. So put your answer in the comment section, and these are the few references. Thank you.